This video is for the Anova test, which is the analysis of variance. This test is used all the time in research because you're looking at numeric measures from more than 2 samples. So if you have numeric measures from 2 samples, you would use a 2-sample test for mean. But the Anova is able to look at mean for more than 2 samples. So in this case, I'm looking at the number of activities that students participate in across all 4 class standings. I can't use a 2-sample test for mean for this because I have 4 different classes, not 2. So for this test for Anova, first thing we need to do is check our assumptions. First assumption of every single test or interval is that your sample is random. So in my case, I randomly chose students to ask them how many activities they participate in. Your sample is going to be random unless you skewed it in some way. Next thing, your samples have to be independent. So the freshmen that I asked how many activities are you involved in have to be unrelated to the sophomores that I asked. This is also going to be the case unless you skewed your data or you had a poor design in some way. The assumption that's really important is that your samples are normal. The way to check that is using a normal quantile plot. So I'm going to show that to you right now on Fathom. So this was the original data set that I gave you. Now the issue is I have these grades and I have the number of activities that they're involved in, but I don't have a way to break up the grades. So what you're going to do is you're actually going to have to put them in a new table. So what I did in this table is I listed the number of activities that the freshmen, sophomores, juniors, and seniors are in. So that's 4 samples, so I need to construct a normal quantile plot for all of them. If I take out a graph, first if I look at the freshman activities, this is a normal quantile plot. What you're looking for in a normal quantile plot is a straight line or very, very close. Now, we're going to notice this is not a straight line. This clustering right here is an issue. So this data set is not normal. I can do the same thing and look at the sophomores. Again, not normal. We have some clustering. Yours will probably be normal. If your data set is not normal, there's another test that you can do. So you're going to need to come talk to either me or talk to your mentor, and we can talk about a different test to do. We're just going to assume that all of the samples are normal or pretty close. So what you're going to do is you're going to do your test. You are doing a test of Anova. Okay, so now here we need the categorical variable and the numeric variable. Our categorical variable is grade, so we're going to go back to the original data set, and we are looking at the number of activities that students are involved in. So this is our analysis. We get a p-value of 0.3, which is greater than 0.05, so we do not have reason to question that students in certain grade levels differ in the amount of activities that they participate in. While it could be that they do differ between class standings, we don't have enough evidence to show that this is the case. As I said in class, normally after you do a hypothesis test, you would do a confidence interval. There is no confidence interval for Anova, so you just stop here.